The Lanchester didn't arrive quietly. It barged onto the battlefield in a rasp of cold steel and hot oil, tyres tearing through mud that swallowed horses whole. Its crew clung inside the cramped hull, trusting a thin skin of riveted armour to keep the world's chaos at bay. The engine coughed, spat, then surged forward, dragging the car across ground no civilian motor would dare approach. It wasn't subtle, it wasn't graceful. In fact, its turning circle was so wide that drivers joked it needed diplomatic clearance before attempting one. Yet, in the fire and fog of early modern war, this machine mattered. The opening months of the First World War demonstrated something brutally simple. Vast armies could now move faster than their ability to understand what they were walking into. Reconnaissance, once the province of light cavalry and spirited young officers with binoculars, collapsed under the weight of trenches, wire, and automatic fire. The British needed eyes that could move, survive, and report, and they needed them at a pace the horse could no longer match. What emerged was not a new branch of cavalry, nor a reinvented messenger system, but a machine with a petrol engine, a steel shell, and the stubborn intention to get information from one place to another before the enemy realized it had gone. This requirement was sharper than it first appeared. Commanders were being asked to make decisions based on reports that were hours old and frequently wrong. A regiment might advance into what they believed was a quiet sector, only to find a German machine gun nest waiting. Equally, an entire corps might pause because no one had been able to confirm whether a road remained open. In such a climate, information was not a luxury. It was a form of ammunition. Anything that improved the speed at which reconnaissance messages travelled would shift the rhythm of battle petrol-powered vehicles, still relatively new technology, seemed an unlikely answer. Yet they were the only machines with the potential to outrun disaster. But moving quickly was only half the problem. Protection was the other. Unarmoured cars, tried briefly in the opening weeks, suffered badly. A single rifle shot could cripple the radiator. A well-placed burst could remove the driver entirely. If the British were going to send men forward in a motorised reconnaissance role, they needed armour, and armour introduced weight demanded power. Power demanded cooling. Cooling demanded airflow that armour tended to restrict. This circle of compromises was the technical crucible that shaped the Lanchester concept long before a single plate was bolted in place. Terrain complicated everything further. The roads of Belgium and northern France were a patchwork of cobbles, dirt, and disintegrating farm tracks. Heavy lorries struggled. Lighter cars broke. Horse-drawn wagons stalled at the slightest incline. Designing a vehicle to operate across this fractured landscape forced engineers to consider issues they had never faced in civilian motoring: torsion through the frame, axle fatigue under asymmetric loads, the scattering effect of shrapnel, and the way mud adhered to wheels like wet concrete. The Lanchester would have to push through all of it while carrying several tons of armour and men who expected to live long enough to return with useful information. There was also the tactical expectation. A reconnaissance vehicle could not merely observe. It had to defend itself long enough to escape. That meant mounting a machine gun in a turret, a feat requiring a stable platform, smooth rotation, and a balance of mass that would not tip the car on uneven ground. Turret height mattered. Armour thickness mattered. Even the angle at which the armour plates were joined influenced the car's survivability. Every improvement added weight, and every kilogram had to be justified in terms of speed and operational endurance. One officer summarized the entire design brief as, "Build us a car that can go everywhere a horse can't, and preferably without losing a wheel on the way." These pressures, strategic, mechanical, and human, formed the backdrop to the Lanchester project. It wasn't created from theoretical doctrine or long-term planning. It was hammered into existence by necessity, forged out of a battlefield that punished slowness and rewarded whoever could see furthest first. In that harsh calculus, the armoured car became the British answer to a rapidly changing style of warfare, one where speed, protection and information were no longer separate considerations, but vital parts of the same machine. The idea of a fully capable British armoured car did not come from those who traditionally oversaw battlefield mobility. It came instead from the Royal Naval Air Service, a group of officers who believed the war would be won not by static lines, but by the ability to move rapidly and strike where the enemy did not expect it. Their aircraft could see far, but couldn't always act on what they witnessed. What the RNAS needed was a ground vehicle fast enough to match the tempo of their reconnaissance flights and durable enough to operate in the chaos they observed from above. For these officers, the Lanchester was not just a machine. It was a way of binding together information and action. The design vision centered on three core ideas. First, mobility. The car had to be fast enough to exploit gaps in the line and reach threatened points before German forces consolidated. Speed alone was insufficient. Endurance was critical. A vehicle that overheated or broke an axle after 10 miles would be worse than useless. The engineers turned to Lanchester's civilian chassis, known for its robustness and unusually advanced suspension geometry. This gave them a starting point unlike any other armoured car project of the time's second, survivability. The armour had to be strong enough to stop rifle fire at the most common engagement distances. This required significant testing of plate thickness, but also the angles at which it should be mounted. Sloped armour was not a widespread idea in 1914, yet the designers intuitively understood that ricochet mattered. The Lanchester's armour was modest by later standards, but intelligently arranged vulnerable components, the radiator, ignition system and fuel supply, received particular attention. In many ways, the vehicle was a moving compromise between what could be protected and what must remain exposed for maintenance. The third idea was command flexibility. A turret-mounted machine gun was non-negotiable for the RNAS teams, who insisted that the car should fight in all directions, not simply forward. This demanded a stable platform of rotating mass atop a vehicle already burdened by armour. Turret balance, traverse smoothness, and sightline clarity became obsessions. Designers experimented with minor shifts in the roofline and mounting ring diameter to find a configuration that wouldn't jam under vibration. Even something as trivial as the shape of the gunner's hatch influenced whether the crew could operate under fire, or if the turret became a claustrophobic trap, debate within naval and army circles intensified. The Admiralty wanted speed and lightness. Some in the army favoured heavier armour and stronger firepower. Engineers were caught between these competing visions, trying to create a vehicle that neither branch would reject. They refined engine placement, adjusted gear ratios, and experimented with cooling vent size until the machine could manage sustained runs without boiling itself to a halt. One RNAS officer remarked that the designers treated every bolt like a moral decision, a dry observation that spoke to the sheer number of compromises required. Yet the most radical insight driving the Lanchester's vision was doctrinal. The RNAS did not see the armoured car as a defensive asset. They saw it as a tool of operational disruption. The intention was to harass German rear areas, destroy signalling stations, interrupt supply, and exploit breakthroughs created by artillery. This concept, mobile, armoured aggression, was decades ahead of its time. In a war largely defined by immobility, the Lanchester represented a strand of thinking that understood movement itself as a weapon. Thus, the vision for the Lanchester Armoured Car was not simply mechanical. It was strategic, a fusion of speed, steel, and audacity, designed to claw back initiative in a conflict that punished inertia. The vehicle was imagined not as a shield, but as a spear, one that could be thrust into the gaps of an ever-changing front, guided by information gathered from above, and delivered at ground level by men willing to trust a car built for a new age of war. The reality of turning an ambitious reconnaissance concept into a functioning armoured car began in workshops that had never planned to build anything for a battlefield. Lanchester's factories, known for precision motor engineering and high-quality touring vehicles, suddenly found themselves requisitioned for a war effort that demanded urgency above elegance. Yet it was this combination, peacetime craftsmanship confronted by wartime necessity, that gave the Lanchester its distinctive mechanical character. The chassis was the foundation. Lanchester's pre-war frame was unusually rigid, thanks to its deep, straight side members, and meticulous riveted construction engineers modified it by strengthening key stress points where the armour weight would be concentrated: the forward third of the frame, the turret mounting ring area, and the rear axle supports. Unlike commercial builds, these modifications required careful recalculation of bending moments along the frame. Too much rigidity, and the structure would crack under battlefield vibration. Too little, and the car would twist out of true, misaligning wheels and binding the steering. The solution was a balanced reinforcement scheme that preserved the original behaviour while enabling it to carry several hundred kilograms of additional mass. Next came the armour. Each plate had to be cut to precise shape, then hammered, drilled, and riveted by men who had often learned their trade building locomotive parts or ship fittings. Plate thickness varied subtly across the hull: thicker at the front to protect the engine and crew compartment, thinner at the rear to reduce overall weight. Armour sections had to overlap at specific points to prevent bullet ingress through seams. This process required a degree of craftsmanship rarely associated with wartime production. Every plate had to sit flush, every curve matched, every rivet head set cleanly. Inconsistent riveting would have created stress risers, leading to metal fatigue after only a few miles of hard running. The engine, a 4.9-litre six-cylinder Lanchester design, underwent its own transformation. Civilian carburettors were replaced with models capable of maintaining mixture under vibration and steep angle changes. Cooling ducts were modified to feed the radiator even when armoured shutters were closed. That required an intricate balance between protection and airflow, a shutter mechanism that could be cracked open by millimetres to bleed heat at low speed without inviting a rifle shot. Crankshaft tolerances were tightened to avoid bearing damage under continuous high load. Mechanics found that even minor alignment issues produced significant power loss once the car was fully armoured. Building the turret introduced another layer of complexity. The rotating mount had to be machined with precision usually reserved for naval components. It relied on a ring of hardened steel bearings around a reinforced collar, capable of supporting the weight of armour, and a machine gun, without binding vertical play in the turret mechanism, had to remain below a few millimetres. Any more, and the gunner would struggle to maintain a firing arc under motion. Engineers repeatedly adjusted the weight distribution to prevent the car from becoming top-heavy, a real danger given its narrow track width. One workshop foreman joked that the safest place to stand during a turret installation was "somewhere the car can't fall on you," a reminder of the precarious balance between stability and firepower. Manufacturing delays were inevitable. Supply chains, already stretched by demands for rifles, artillery and shells, struggled to deliver the high-grade steel required for armour plate rivets. Surprisingly, became a bottleneck. The quality required meant only certain suppliers could produce them, and their output fluctuated with the availability of skilled labour. Yet, despite these challenges, the build proceeded with remarkable consistency. Each Lanchester emerging from the factory carried the same design DNA: rigid, loud, mechanically honest. The culmination of this labour was a machine that bore the marks of both careful engineering and battlefield pragmatism. Every plate, rivet and casting represented a choice: where to add weight, where to shave off grams, where to protect, where to simplify. The result was not perfect, nor was it meant to be. It was a machine built to meet a moment in history, created by engineers who understood that durability was not just a specification, but a survival requirement. Testing the Lanchester was not a matter of waiting for perfect weather and a calm parade ground. The Army needed to know how the vehicle behaved when pushed, rattled, shaken, and generally bullied by the kinds of conditions that ruined lesser machines. Trials began on rough ground where ruts formed faster than they could be filled, and where a motor car built for civilian life would have shuddered into scrap. Crews climbed aboard with notebooks, oil cans, and an optimism that, by all accounts, faded within the first 10 minutes of running. Steering effort doubled on soft ground. The car lurched violently over unseen depressions, and mud adhered to the wheels so thickly that the engine had to fight for every yard of progress. One of the first revelations concerned weight distribution. On paper, the Lanchester seemed balanced enough, its armour centred, its turret not excessively top-heavy, and its fuel tank placed low. In practice, the front axle carried an unwelcome share of the burden. On slopes, steering became uncooperative, the wheels dug in instead of climbing through, and the turning circle, already generous, expanded to near comical proportions. It took tact, finesse, and a degree of stubbornness to coax the car into tight manoeuvres. Drivers quickly learned to anticipate corners well in advance or face the embarrassment of overshooting them entirely. One tester quipped that reversing a Lanchester felt like asking a wardrobe to dance. Mechanical stresses revealed other quirks. The turret mechanism, precise in the workshop, sometimes jolted under vibration, causing misalignment between the ring and its bearings. Crews reported moments where the turret seemed to hesitate before continuing its rotation, prompting engineers to revise the bearing collar and harden select surfaces. Engine mounts had to be reinforced as well. Sustained vibration loosened bolts, sometimes enough to create audible clunks that unnerved drivers. The carburettor, despite improvements, struggled to maintain mixture over rough ground, leading to uneven firing at low speeds. Cooling remained a persistent concern. Armour shutters, essential for protection, restricted airflow during prolonged idling or hill climbs. Temperatures climbed rapidly, forcing crews to open shutters at intervals and expose the vulnerable. Radiator engineers experimented with small relief notches and redesigned vent shapes to balance airflow with safety. These modifications, though minor in form, gained outsized importance during longer test runs. Field handling under fire conditions introduced another dimension. Test crews simulated attacks using blank rounds and smoke, attempting to replicate battlefield stress. The gunner's position was cramped but functional, with decent traverse speed and reasonable ergonomics given the era. Accuracy at speed, however, proved more aspiration than reality. The Lanchester's suspension did not forgive sudden movement. A sharp jolt could send rounds wide or force the gunner to recalibrate entirely. Still, the ability to return fire from a mobile platform was a significant advantage over cavalry scouts, who had little recourse beyond concealment. Visibility tests uncovered predictable limitations: armour plate made for narrow viewing slits, and dust thrown up by the wheels often obscured the driver's forward view. Commanders riding in the rear compartment developed hand signals for communication, tapping the driver's shoulder to indicate adjustments in speed or direction. Despite these constraints, crews generally agreed the Lanchester offered far more protection and operational confidence than anything they had used before. The ability to cross contested ground at speed, even imperfectly, was a revelation. The trials revealed flaws, but they also confirmed promise. The Lanchester did not break under stress. It adapted. Engineers revised a dozen details, from the turret collar to the carburettor jets, and crews learned the vehicle's temperament. It was stubborn, lively, occasionally exasperating, but fundamentally sound. With each test run, it proved itself a machine that, for all its quirks, could shoulder the demands of reconnaissance in a battlefield environment defined by unpredictability. The Lanchester's moment of truth came not on British soil, but on the long, punishing expanses of the Eastern Front. Russia, desperate for mobile firepower, became the largest foreign user of the vehicle. What followed was a test far beyond anything the British had anticipated. The roads, when they existed, were little more than wide scars of mud, and churned earth distances were astonishing. Supply lines fragile, and weather conditions swung from brutal cold to knee-deep slush in a matter of days. If the Lanchester was going to succeed anywhere, it would be here. If it was going to fail, it would be here as well. The initial reports from Russian crews were cautiously optimistic. The Lanchester could cover ground far faster than infantry units and had enough power to push through moderate mud. Its engine, though prone to heating under armour shutters, generally behaved well in colder climates. Gun traverse was smooth, and the vehicle's internal space, while certainly not comfortable, was considered more manageable than several Russian-designed alternatives. Early engagements showed the vehicle could deliver suppressing fire, exploit openings, and relocate rapidly when the situation deteriorated, but the Eastern Front was cruel to anything with wheels. The first major limitation emerged almost immediately: ground clearance. The Lanchester had been designed with European roads in mind, not the vast rutted plains of Galicia. In deep mud, the wheels sank until the axles brushed the soil, robbing the car of its ability to move forward. Recovery often required teams of horses or multiple vehicles chained together. The now famous photograph of Russian crews attempting to free a bogged Lanchester captured the sheer frustration of the task. The car's weight, once a symbol of protection, became its anchor. Mechanical endurance also revealed weak points. The suspension struggled under the ceaseless vibration of rough terrain. Bushings wore out quickly, wheel bearings heated, and the steering components sometimes loosened under continuous stress. Russian mechanics adapted by performing rigorous daily maintenance. Grease points were serviced religiously, bolts tightened constantly, and improvised support brackets sometimes welded into place during night halts. These ad hoc repairs extended the life of many vehicles far beyond what the designers had imagined. Strategically, the Lanchester demonstrated undeniable value. It provided reconnaissance capability across frontline sectors, delivered firepower where infantry struggled to move, and served as a mobile command platform for officers needing real-time awareness. Russian units reported that even a small number of Lanchesters could stiffen defences or energize an attack by providing a sense of mobility otherwise absent on such a static front. In some instances, they were used aggressively to disrupt enemy flanking manoeuvres. In others, they performed courier duties between isolated formations. However, the same attributes that made the Lanchester formidable also limited its long-term viability. Tyres proved vulnerable to shrapnel and debris. Radiator armour, while improved, still required cautious management of engine temperature. The narrow track width and high centre of gravity amplified stability issues on uneven ground. These were not fatal flaws, but they were constant reminders that the vehicle was fighting in a theatre for which it had never truly been intended. Russian commanders praised its reliability compared with other foreign designs, but criticized its inability to operate in the worst conditions of the front. This duality, useful yet impractical, powerful yet restrained by its own weight, defined the Lanchester's wartime experience. One Russian officer put it bluntly: "It is a fine machine, so long as one avoids the places where war is happening." The wit was harsh, but not entirely unfair. The car excelled in mobility until the terrain turned hostile, at which point physics won every argument. Even with these contradictions, the Lanchester carved out a respectable combat record. It never became the dominant armoured vehicle of the Eastern Front, nor was it intended to be. Instead, it occupied a narrow but essential niche: fast, armed, protected reconnaissance in a war where such capabilities were desperately scarce. Its successes and failures became lessons for future designs, illustrating the need for wider tracks, greater ground clearance, and drivetrains built expressly for hostile terrain. The vehicle had not solved the problem of mobility in modern warfare, but it had revealed the shape of the solution. The Lanchester's story did not end with the collapse of the Eastern Front or the armistice in the West. Instead, it migrated, quietly, almost unnoticed, into new theatres, where its presence shaped events far beyond its original design intent. The most striking of these aftershocks occurred in Britain's colonial territories, where the armoured car became a tool not of conventional battle, but of administration, intimidation, and the tenuous projection of authority across vast, difficult landscapes. In Malaya, long before the crisis of the post-war emergency, the Lanchester re-emerged as a symbol of mobile order, patrolling plantations, escorting convoys, and responding to uprisings where roads were barely worthy of the name. In these environments, the car's limitations revealed new consequences. The narrow wheelbase, which had hindered stability on European mud, proved equally imperfect on tropical tracks, where monsoon rains transformed laterite soil into clay and deep ruts formed overnight. Yet colonial police forces and army units valued the Lanchester for qualities that had once been considered secondary: its psychological presence and its survivability in ambush conditions. The armour that struggled on the Eastern Front suddenly became an asset against small arms fire in thick terrain. Crews felt safer behind steel than in open trucks, and commanders viewed the armoured car as a reassuring bridge between firepower and visibility. Its use in Malaya also revealed an economic implication. Maintaining older armoured vehicles in distant territories created a logistical ecosystem that persisted long after the cars themselves were outclassed, workshops were built, spare parts caches established, fuel depots extended to accommodate reconnaissance patrols. This infrastructure, born of necessity, remained in place for years and influenced how British forces prepared for later crises. Even obsolete machines can leave indelible traces not by their presence, but by the support networks erected to keep them alive. The Lanchester's continued service exposed another subtle but significant consequence: doctrine drift. Vehicles built for reconnaissance in open war found themselves repurposed for internal security. Their mobility patterns changed, radio usage evolved, crews developed new tactics such as staged overwatch positions on ridge lines or staggered convoy formation to minimize ambush vulnerability. These adaptations were not written into manuals, but learned by repeated exposure to threat. Armoured cars became moving observation posts, deterrent patrollers, and symbols of authority in regions where British control required both visibility and caution. Propaganda absorbed the Lanchester as well. Colonial administrators photographed the cars in training, presenting them as evidence of stability and technological reach. Publications framed them as guardians of the road, projecting an image of quiet strength. Yet, behind these portrayals lay a more complex reality. Older machines required more maintenance than new ones, demanded constant adjustment to tropical climates, and often stretched supply chains to their limits. Mechanics spent hours mitigating corrosion, adjusting carburetors for humid conditions, and servicing suspensions that groaned under loads for which they had never been designed. A further, less visible consequence emerged in the minds of the soldiers who operated them. Many crews, often young, often far from home, developed an intimacy with the vehicle that shaped how they interpreted their mission. The Lanchester felt both outdated and dependable, a contradiction that mirrored Britain's evolving position in its colonial holdings. It was a machine from an earlier age still being asked to project 20th century authority. One sergeant remarked that the car had more lives than our posting orders, a dry comment that captured both its persistence and its stubborn refusal to become irrelevant. The Lanchester, in surviving beyond its intended era, influenced operations, logistics, doctrine, and even perception. It was not heroic in this phase. It was practical. It carried officers, signallers, and patrols into regions where foot travel was too slow or too dangerous. It served as a moving reminder that technology, once deployed, shapes the world long after its designers have moved on. Its hidden consequence was continuity, the way an old machine can become part of the scaffolding of power, quietly maintaining a presence even as history shifts around it. By the time the Second World War reshaped the global order, the Lanchester had long since ceased to be a frontline machine. Yet its legacy did not vanish with its military retirement. Instead, it shifted into the quieter but arguably more influential domain of design lineage, the realm where older ideas echo through newer machines and where the technical lessons of one generation reappear, refined, in the next. Engineers who studied the Lanchester in the interwar years absorbed principles that would inform the armoured cars of the 1930s and early 1940s. Principles of chassis stiffness, turret balance, cooling management, and the importance of placing critical components low and central for stability. One of the clearest legacies lay in British six-wheeled armoured car development vehicles, such as the Rolls-Royce 1920 pattern, the Morris CS9, and the later Humber series, each inherited ideas first tested on the Lanchester. The need for a rigid frame capable of carrying armour without twisting was carried forward almost verbatim. Designers adopted stronger cross members, boxed sections, and reinforced mounting points, concepts pioneered, at least in part, to cope with the Lanchester's early structural loads. Later vehicles also benefited from improved turret rings, drawing directly on the lessons of binding bearings, misalignment under vibration, and the need for hardened surfaces. These refinements contributed to more capable reconnaissance platforms across the Empire. In a broader sense, the Lanchester helped normalize the concept of the armoured car as an indispensable tool rather than a stopgap novelty. When the First World War ended, many planners assumed these vehicles would fade into irrelevance. But the Lanchester's adaptability and its widespread operational use proved otherwise. By the 1930s, armoured car units had become a staple component of British doctrine, especially for colonial policing and mobile scouting. They were expected to serve not only in reconnaissance roles, but also as fast-moving fire support, convoy escorts, and rapid response vehicles, tasks once explored tentatively by the Lanchester on battlefields from Belgium to Armenia. A second strand of legacy came through the maintenance culture the Lanchester inadvertently created. Units that operated it learned the value of rigorous daily mechanical checks. The vehicle demanded respect, regular lubrication cycles, careful inspection of steering components, and constant monitoring of overheating risks. This attention to preventative maintenance became ingrained in armoured car units long after the Lanchester had been retired. The philosophy that a mobile unit must be mechanically perfect before it is anything else became a doctrinal expectation in British reconnaissance formations. The Lanchester also influenced the way mobility and firepower were paired. Its rotating turret, though primitive, sent a clear signal. Reconnaissance units needed the ability to fight in any direction, not as a primary task, but as a survival requirement. Later cars adopted fully enclosed turrets with higher calibers, improved optics, and better stabilization. Yet the foundational logic remained unchanged. A scouting vehicle had to be able to defend itself decisively. Even the shift towards heavier, all-wheel drive cars in the late 1930s carried forward the earlier understanding that terrain, not theory, dictated the true value of mobility. Finally, there is the legacy preserved through the surviving examples. The Lanchester at Bovington, angular, imposing, unmistakably early war in its proportions, demonstrates the scale of ambition behind the original design. It is a machine from a formative moment in mechanized warfare, embodying the learning curve of engineers who were moving from Edwardian luxury motoring into the violent modernity of armoured combat. Its construction speaks to a time when every rivet was a design decision, and when battlefield mobility still felt like a frontier being explored. One museum technician once joked that it has the personality of an Edwardian battleship wearing bicycle wheels, and while the remark was light-hearted, it captured the hybrid identity of a vehicle straddling two eras. The Lanchester's legacy is therefore less about fame and more about foundations. It gave British armoured doctrine a starting point, a template from which engineers and commanders could iterate. It proved that steel and speed could coexist, that reconnaissance required protection, and that mobility would dominate modern warfare as surely as firepower. Many vehicles that followed were faster, stronger, and more advanced, but they carried, in their geometry and their philosophy, the lessons first shaped by the Lanchester, less glamorous than some of its contemporaries, but unquestionably influential in the evolving story of mechanized reconnaissance. The Lanchester's story closes in a world very different from the one in which it was conceived. Its birth was hurried, its service uneven, and its reputation shaped more by the terrain it crossed than the battles it fought. Yet, when viewed from a distance, when the noise fades and only the outlines remain, it becomes clear that the Lanchester marked a turning point in how armies understood mobility. It was a machine caught between eras, too modern for the world that existed before 1914, yet not quite ready for the mechanized age that followed, and in that liminal space it helped define what armoured movement could be. Returning to the themes of its early career, the car was always engaged in a struggle with the landscape. Whether on Belgian pavements, Galician mud, or Malayan tracks, it met ground conditions with both capability and limitation. The contrast was instructive. In places where the terrain cooperated, the Lanchester was fast, assertive, and tactically decisive. Where it did not, the vehicle became a lesson in physics and humility. This duality, performance tied directly to environment, echoes through the development of every armoured vehicle that followed. Designers eventually learned that mobility required not only power, but an understanding of the surfaces beneath the wheels. Its mechanical character left its own imprint. The Lanchester taught engineers that armour weight could not simply be added to a civilian chassis. Without consequence, suspension geometry mattered. Bearing alignment mattered. Cooling systems were not optional extras, but the lifeblood of the machine. These insights evolved into formal engineering practice, guiding how armoured cars and tanks were built for decades. The Lanchester, in effect, forced the convergence of automotive engineering with battlefield necessity, a marriage that produced the standards upon which mechanized warfare now rests. Perhaps its most lasting contribution, however, lies in the way it altered the relationship between reconnaissance and protection. Before the Lanchester, scouts were expected to be fast but vulnerable, gathering information at the risk of their own survival. After the Lanchester, speed and protection became intertwined. A reconnaissance unit had to return with what it had learned, not merely attempt to collect it. This shift in thinking shaped doctrine throughout the 20th century, influencing everything from armoured car reconnaissance to helicopter scouting and drone operations. The principle was universal. Information is only as useful as the platform that carries it back. There is also a quieter dimension to its influence. Machines like the Lanchester do not vanish when they are retired. They linger in the habits, expectations, and instincts of the people who operated them. Crews learned to listen to the engine's cadence, to feel the chassis flex under strain, to anticipate the way the wheels would behave on certain surfaces. These experiences formed a tacit knowledge base, one passed informally between generations of soldiers and mechanics. Tools might change, but the mindset forged through the Lanchester's quirks continued to shape how operators evaluated threats, terrain, and mechanical limits. One veteran remarked that, "The car taught us to respect anything with a crankshaft," capturing the blend of humour and engineering respect that defined the machine's legacy. As with many early military vehicles, the Lanchester eventually ended up in scrapyards, workshops, and finally museums, where it stands not as an icon, but as a testament to experimentation. It represents the moment when armies began to trust machines not simply as transport, but as active participants in the fight. It showed that mobility could be armoured, that information could move at speed, and that even imperfect vehicles could change doctrine. In the end, the Lanchester's importance lies in its role as a bridge, a link between improvised wartime necessity and the structured mechanization that followed. Its rivets, plates, and wheels carried more than a crew. They carried the first real attempt to solve the puzzle of armoured mobility. Though overshadowed by the tanks and armoured cars that succeeded it, the Lanchester remains a crucial part of that lineage. Its lessons endured, its influence continued, and its presence can still be felt in the vehicles that roam modern battlefields. The Lanchester was not perfect, but it was pivotal.